part of our exponent and power unit. And our learning target today, you can translate between standard and scientific notation. So we're not doing everything. Tomorrow we'll deal with identifying proper scientific notation. Today we're going to deal with the standard form and scientific notation form. And who remembers from science, King Henry died unexpectedly drinking chocolate milk? Anybody remember that?
Yeah.
And that's how we converted units in the metric system, right? So we'd have our standard unit, and then we'd move our decimal places over. Do you remember that? And that's all scientific notation is really. So this science of conversion is really scientific notation. So if you remember, if you wanted to, if you had 120 meters and you wanted to turn it to how many centimeters, you would go 1, 2. Wouldn't you go 2 spots over? And so it'd be 120 plus 2 more zeros, okay, centimeters. So that's scientific notation. All scientific notation is moving a decimal. And you need to know how many spots do you need to move it. And you know what? Something tells you how many spots you need to move it. It always looks like this. 3.4 times 10 to the -8. Scientific notation is always timesing by some kind of power of 10. And this power of 10 is what tells us how many spots to move. So here's some properties of scientific notation. The decimals always move. So the decimals are moving constantly. That's the heart of scientific notation. We are moving decimals around. Just like that scientific connection here with the converting metric units, all we do is move decimals around. That's scientific notation. If it's a positive exponent, so positive exponents means that you move to the right because you're getting bigger. So positive exponents tells you how many spots to move to the right. Negative exponents tells you that you're getting smaller. You move to the left. But the answer never becomes negative, ever. It just means you move your answer or your decimal to the left. And then this is more with tomorrow's learning target. The numbers are always between 1 and 9. Meaning like 4.6 times 10 to the third. Or 1.7 times 10 to the -8. I want you to write those 2 examples down because we're going to analyze this a little bit. So this first example, this power of 10 just tells me, you see where this decimal is on 4.6? This says move it 3 to the right. That's all that exponent tells me to do. The 10 just tells you what to do with your decimal. So 10 to the +3 says move the decimal +3 spots to the right. 10 to the -8, all I care about is this -8. And that -8 is just telling me what to do with the decimal. And it's telling me that I need to move 8 to the left because it's negative. And we'll practice, but I just wanted to show you how I read this. I don't go 4.6 times it by 10 and then move it. All I do is look at the power of 10, and that tells me what to do with this decimal. Okay? Flip that page over. And we're going to do the second box first. Okay, so if we want to write in standard form, standard means it's what we always do. There's standard form and there's scientific notation. Scientific notation is always times some power of 10. Standard is just normal numbers we're used to. So this is written in scientific notation. I want to convert it to standard. What we do is move the decimal as many spots as the exponent tells us to. So this first one, my exponent is 5. It's a positive 5. So does that mean I need to move to the left or the right? Right. So I'm going to go ahead and move it 5 spots to the right. Here's 1 spot, 2 spots, 3 spots, 4 spots, 5 spots. I'm just showing you my hopping, like my decimal hopping over. I had to add placeholder 0 so I could continue hopping. So that, then you have to make it look nice. 320,000 is what it is in standard form. You don't have to show the hopping, I just do it when I first instruct you. Some of you can think logically about this right away. You think, oh, I can go 1, I have to go 5, so I can go 1 spot to get to the end, and then I would need 1, 2, 3, 4 placeholder zeros. That's a logical way to think about it. 2.043 times 10 to the negative 5. So my exponent is negative 5. So does that mean left or right? Left. I need to move to the left. So I can move 1 spot to the left. And then how many placeholder zeros do I need? 4. So 1, 2, 3, 4 placeholder zeros. 2, 0, 4, 3. Nope, that's to the left. And then 1, 2, 3, 4, 5. Okay, just showing you the hopping. 1, 2, 3, 4. Oh, oopsie, I have 1 0 too much. Darn it. 1 spot, 2, 3, 4, 5 spots. So all today is moving a decimal. You just have to be able to analyze. One other translating though. Sometimes you have to translate numbers written in standard form and turn it to scientific notation. And that's the purpose for scientific notation is to take these ginormous numbers that have too many zeros and just kind of congest it up a little bit so it doesn't look so long and your eyes don't get all crazy looking at all those zeros. So this is where I said the first number is always between 1 and 9. What we do is take the first non-zero digit, 7, and put the decimal after it. So it would be 7.5. And then we tell the problem solver how do you get to the original form. So I have to times 10 to the, and how many spots do they need to move it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9 because I have to go to the left. Do you see how I did that? So I found my first non-zero digit. I put a decimal right after it. And then I told you write the exponent that gets you back to where you started. So my decimal is really always at the end here. I go to my first non-zero digit, 3. You write all of the numbers down that are not 0 except if it's smushed in between 2 non-zero numbers. 3.105. Now I end in zeros, so now I can say times 10 to the, and then I need to count how many spots would I need to go to get to the right. Pay attention to me. How many spots to get back to where I started? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Positive because I went to the right. So not very rigorous. You should be able to translate between these two forms. Just remember to watch the video if you forget or re-look at your notes.